Let's go ahead and take a look at the test 7 review. For numbers 1 to 3, we're going to solve each proportion. So whenever we're doing these problems, we're going to multiply diagonally. So I have 6 times the quantity, 2x minus 3. So the parentheses there, they are necessary, which is equal to 10 times the quantity, x plus 8. And whenever we have a number right next to the parentheses, you're going to apply the distributive property. So this is what you need to do. So 6 times 2x is 12x, 6 times negative 3 is minus 18, or negative 18, which is equal to 10 times x, that's 10x, and then 10 times positive 8 is plus 80. So if I subtract both sides by 10x, and at the same time add both sides by 18, I should get 2x is equal to 98. So dividing both sides by 2, that should leave you with x is 49. That's your answer. For number 2, again, we're going to multiply diagonally. So I have 7 times 9. And I equal that to 14 times x. So 7 times 9 is 63, and 14 times x is just 14x. So x is 4.5. Number 3, I got 20 times the quantity, 2x plus 1, and I want to equal that to 10 times 8x. Using the distributive property, I have 40x plus 20, and on the right hand side I have 80x. So if I subtract both sides by 40x, I get 20 equals 40x. Then I divide both sides by, not 40x, just 40. I'm going to divide both sides by 40. So I have x equals, 20 over 4, that reduces to, that's 2 over 4. So 20 over 4 is the same thing as 2 over 4, but that reduces to 1/2. So that is your answer. So now we're going to go ahead and look at simplifying radicals. I have number 4, the square root of 98. So what two numbers multiply together that'll give me the square root of 98? Well, that's going to be the square root of 49 times the square root of 2. So I have a perfect square. The square root of 49 is 7, whereas I have the square root of 2. 2 is not a perfect square, so you're going to leave it alone. So your answer is 7 root 2. I have the square root of 45. What two numbers multiply together that will give me 45? I have 9 and 5. I have 9 here, which I can break down. That's 3 and 3. And this 5, if I break it down, it's going to be 1 and 5. So you're going to leave that alone. So I can go ahead and circle the pair of 3s and underline that 5 because this is a pair and 5 does not have a pair. So what do? Well, I have 3 root 5. You're going to look at that pair. You're going to eliminate one of the 3s, and that other 3 will go outside of the square root. And if there was a number here originally, you're going to multiply 3 by that number. So if there's a number here, multiply 3 by that number. Number 6. So what two numbers multiply together that'll give me 28? If we're struggling with that, I highly recommend that you use your calculator. So you're going to do 28, you're going to input 28, press the division sign, and then you're going to punch in a number that's greater than 1. So let's see. 28 divided by 2. Great. You got 14. So I'm going to write 14. And the number that you use to divide 28, which in this case is 2. See that? And you can keep on doing that with your calculator, especially with this 14 here. So if I put that in the calculator, I can do 14 divided by 2. That should give you 7 and 2. Look at that. You got a pair of 2s. And you have that 7, which is that lonely number. So I should get 2 root 7 as your answer. Number 7, I can do the square root of 4 times the square root of 3. 4 is a perfect square, so I can say 2 root 3. That's my answer. Or if you did something like this, you did the square root of 6 times the square root of 3, well, you're going to be like, oh, well, I guess the answer is the square root of 12 then. I can't simplify that because 6 is not a perfect square. No, break down that 6 into the square root of 3 times the square root of 2, because the square root of 6, well, you can break that into the square root of 3 times the square root of 2, or I should say the square root of 3 times the square root of 2 is the square root of 6, okay? And look at that. I have the square root of 3. Don't forget about that. So I can multiply that with these numbers here. And if I were to multiply the square root of 3 times the square root of 3, that is the square root of 9. And don't forget that root 2 there. And y'all, the square root of 9 is 3. So you multiply that with the root 2, this is your answer. Okay? But really, I think the best numbers here you should have already started off with are the square root of 4 times 3. Oh, look at that. Number 8. You have a number here. Don't forget it. So it's 4 times the square root of 125. So I'm going to use my calculator and input some numbers into my calculator. So I have 125 divided by, well, 125. That 25 gives me a hint. I'm thinking quarters here, so 125 divided by 25. That's going to give you 5, right? So I can say 5 times, well, 25. So break down the 25 here. That's 5 and 5. Circle it because those two numbers are the same. So this goes away, and this 5 is now going to go outside of the square root, and this 4 needs to be with that 5. And where does this 5 go? It goes right here. So 20 root 5. $128, or I'm sorry, the 2 times the square root of 128. So if we can't think of two numbers that multiply together to give me 128, you do 128 divided by a number greater than 1. So 128 divided by 2, boom, 64. Look at that. So I can say 2 times the square root of 64 times 2, which is 2 times the square root of 64 times the square root of 2. So 2 times, well, the square root of 64 is 8. Root 2, 16 root 2. For 10 and 11, it says determine whether each pair of figures is similar. If so, write the similarity statement and the scale ratio. If not, explain your reasoning. So, we need to list all the corresponding angles congruent and see if the corresponding sides are proportional. I can see that angle B and angle F, they are congruent, they have one arc, and they're also on the top left corner of, each figure here, respectively. Well, I can say angle B is congruent to angle F, and that's the same thing with angle C and angle G. And what else we have? We have angle A congruent to angle E. And lastly, I'm going to use a different highlighter here. Angle D is congruent to angle H. So, now that I show that the corresponding angles are congruent, the question is, are the corresponding sides proportional? So, we have these two sides. We have the left side of the figure here, or the two figures here. I'm going to say AB over EF equal that of 4 to 10, which reduces to 2 over 5. Then I'm going to look at the top sides. So BC corresponds with FG. That's 6 to 16, and that reduces to 3 over 8. Now, if I look at these two ratios here, are they proportional to each other? Are they equal to each other? No. So 2 over 5 is not equal to 3 over 8. So what does that mean? They are not similar. So, since they are not similar, you do not need to write the similarity statement. Let's take a look at these two figures. Okay, so these two figures are quadrilaterals, and they have the 90-degree angle. So if they have 90-degree angles, that implies that this is also 90 degrees, and this is also 90 degrees. Okay, so I have the top left corner. I'm going to compare that to this top left corner. So angle W is congruent to angle N. Angle Z is congruent to angle Q. Angle X is congruent to angle P. And also angle Y is congruent to angle R. So the corresponding angles are congruent. So now I need to look at the corresponding sides. Let's take a look at WX and NP. So WX to NP, that is, 4 to nothing. So my bad, shouldn't have used that. I should have used, I can, because this is something that I didn't catch on. So I have 4, 10, nothing here, nothing here. Well, this is a rectangle, and one of the properties of a rectangle is that opposite sides are congruent. So if this is 4, that has to be 4. And if this is 10, that has to be 10. And if this is 18, this has to be 18. And if this is 9, that's 9. So yes, I actually can say that WX is proportional to, or not proportional, I can say that WX corresponds with NP. They're not proportional. So just know that this side is corresponding with that side there. So 4 to 9, great. So I have 4 over 9. Now let's take a look at the two corresponding sides. So WZ over NQ, which is 10 over 18, reduces to 5 over 9. So if I look at these two ratios here, 4 over 9 is not equal to 5 over 9. They are not equal to each other. So I can say that these two figures are not proportional. So not proportional. And I want to emphasize that when you're comparing figures that are not triangles, you're going to do this process. Whereas if you're determining whether the triangles are similar, well, you will be using the similarity theorems: side angle similarity, angle similarity, or side similarity. Okay, so please make sure if you are trying to compare two triangles, or I should say, if you're trying to determine whether the triangles are similar, then you're going to be using one of these similarity theorems to prove if they are indeed similar. For instance, number 12, I got these two triangles. Are these two triangles similar? I can see that angle G is congruent to angle M. And I can see that angle V is congruent to angle B. So if I have, two pairs of corresponding angles that are congruent, then I can say that these two figures, or these two triangles, are similar because of the angle-angle similarity. So since they are similar, this is where I have to write my similarity statement. I can say GFC. This is where you can say whatever you want as long as you are, going around the figure. So I'm going to GVC. So GVC is similar to triangle. And then this is where the other half, you have to be consistent. You have to write it in order of correspondence. So what corresponds with G? We said M. So M. What corresponds with V? We said B. So that means that C has to be corresponding with H. That's how you write your similarity statement. Let's take a look at 13. Okay. Oh, am I supposed to find X? Yes, I'm supposed to find X. I did not read the problem here. Okay. We need to find our scale ratio. So I know that VG corresponds with BM. So I have 12 to 16, and that reduces to 3/4. Now take that 3/4. Notice that 12 came from this figure, and then the 16 came from that figure. So I want to equal that to X, which came from the figure with 12. And I'm going to put that over 22. So 4X is equal to 22 times 3. Do I have enough room? So 4X is 22 times 3. 22 times 3 is 66. So X is equal to 66 divided by 4, 16.5. I'm going to go ahead and take a look at my key and verify if that is my answer. Yes, X is equal to 16.5. Okay, lots of steps. Please make sure you're reading the directions carefully. Okay, let's look at these two triangles. Again, we're going to prove whether or not these two triangles are similar using side angle similarity, angle similarity, or side similar. Or possibly they are not similar. And if they're not similar, we're going to write NP. So I have these two arrows. they indicate that they are parallel to each other. So we can safely say that there are parallel lines cut by, well, two transversals if we look at it. So here's a transversal and here's a transversal. So angle A has to be congruent to angle D, and angle C is congruent to angle E. So these two triangles here, so triangle ABC is similar to triangle DBE by angle similarity. So then this is where I have to find x, and to do that I need to find my scale ratio first. So the scale ratio, okay, so AC has to correspond with ED, right? So look, I have AC, the first and the last, that should correspond with the first and the last on the other side of the similarity statement. So AC over DE is equal to 30 over 60, which is 1/2. So my scale ratio is 1/2, so 1/2 equals, well, CB, half is equal to X equals CB, and CB corresponds with BE, so 38.6. So 2x equals 38.6, so x is 19.3. That's your answer.